Hi everyone, my name is Chen. Today I'm going to present my work about the phrase grounding. Given a picture and a natural language query, phrase grounding requires to localize all the mentioned objects in the picture. Typically, a phrase grounding system involves 3 steps. First, we propose a set of proposals as candidates. The second step involves multimodal correlation to correlate the queries and proposals. And finally, we retrieve the most related proposal as a grounding result. However, there are 2 important limitations. First, independent proposal generator cannot cover all the mentioned objects. Considering these examples, we can easily find a man, a little girl, or a guitar. But when we want to find the photo near the girl, it is not in the candidate sets, so there's a natural performance upper bound for it. So the first motivation is that we want to generate and regress each proposal based on the query semantics. And the second limitation is that the context information is ignored. For example, when the query is a man, a little girl, or a guitar can be its context. When we find a proposal containing a little girl or guitar, we can easily filter out these proposals because it is not the proposal we want to find. So based on these findings, we propose the second motivation, which is try to use the useful cues in the context information to filter out unrelated proposals. Based on these 2 motivations, we propose a QRC network, which contains 3 parts. The first one is called the Proposal Generation Network, which tries to generate a set of proposals and use ROI pooling to extract visual features. The second one is called the Query-guided Regression Network, which tries to regress each proposal based on the query semantics. We feed both language and visual features and trying to predict both the regression parameters and probability distribution. And don't forget, we still have the context information. So we propose another context policy network. Based on the QRN's prediction results, the CPN tries to rank these proposals and assign reward for each proposal, considering whether it is foreground, background, or context, and backpropagates this reward as policy gradient to guide the training of PGN and the QRN. And we evaluate the QRC Net on 2 popular grounding datasets. First is a Flickr 30K entities, and second one is a Referit game dataset. Both of them containing more than 20,000 images, and each image is associated with several queries. And we find that on Flickr 30K entities, QRC Net achieves more than 15% increase in accuracy, and on Flickr Referit game dataset, we achieve more than 17% increase in accuracy. We further show that for different types of queries, QRC Net achieves consistent improvement in accuracy. And finally, we visualize some grounding results, and we can see that QRC Net can ground the correct object in most times. And to sum up, the QRC Net adopts regression mechanism to break the performance upper bound, and we introduce reinforcement learning to leverage context information, and we achieve the state-of-the-art performance on 2 popular datasets. And more details can be seen in the number 8 poster session. Thank you.